recap of what group summary statistics and how we would calculate those. And then I'm going to move on to the other basic data munging functions that you would use in Spark. So first off, this is what you would go through here. You'll have to rerun every time, but the data set's pretty small. So we're pulling in LinkedIn data from the World Bank for international countries and talent migration. So quickly, I'm not going to go over the more simple example. Please, if you need a refresher, go to my website and watch that video. But you will see this a couple times today periodically, so I can go over this really quickly. So in order to do summary statistics, either multiple different types of summary statistics or looking at multiple variables, in order to do that, you have to put them inside. Well, first you group the data set by whatever you want to group it by. This is required for doing a group summary statistics. You can't just go directly to aggregate. After that, you can use the aggregate function. You can see here that the entire text is located between these two parentheses, and each individual line has a different summary statistic here. Usually the default would give you names that aren't really ideal. Saying in this case, you can see the average and it has the parentheses around it. We don't want column names with special characters in them other than underscores. So the alias function then allows you to rename that, and whatever data frame you end up with will have that name for each one of these summary statistics. So when you use a single summary statistic, is particularly the average is an example, you do not need to load in the package for average. That when you start using the aggregate function, you actually do have to load in the function right here. The example is shown here. That's something that I ran into when I first started working on this. So keep that in mind. Once you start using aggregate, you have to read these in and import those functions. And then finally, tacked on to this part, I have an order by statement where I'm taking all the data and sorting in ascending order based on the 2018 column. So our final output, you can see, has these column names that I specified. It's in ascending order, and it has the different metrics at the mean for those metrics. So that's it for my quick recap on the summary statistics. Are there any questions? I can see the chat. If you would prefer that option, feel free to write something there or to unmute if that's easier for you. All right. So the next thing I'm going to show is the show function. So at the top, I've been using something called display. So I've been wrapping the data frame in display, so you can see that here. If you're using a very big data set, which we're actually going to fool around with a much larger data set next time in next class. So it's going to make more difference in that case. Always use show instead of the display with those large data sets. That just takes less processing power. It pulls fewer rows, and it doesn't cause so much of a memory hog on your master node of your cluster. So I recommend definitely using that if at all possible. So the next thing might be great if you're an introductory PySpark user. So I took this from a Databricks training that I did, so got to give them full credit for these visualizations here. Databricks has an option called Koalas that allows you to actually run Pandas Python code with the same syntax, but have it distributed across a cluster. So it's parallelized and works much faster. So you can see that here. We're looking at the different speeds for Pandas versus the Koalas and your normal PySpark, which is what I'm showing today, which if you don't know it, you're required to learn a variation of Python, so some new coding. So as your data set grows, you see a big difference between the three options. So really at the beginning, where you have a relatively small data set, the difference is very, very small. But when you start to get to like a medium-sized data set, you start to see a difference where Pandas is running slower. Koalas will be somewhere in the middle, and then PySpark tends to be the most quick of all of them. And if you come over here, when you have a much larger data set, you can see that there is a massive difference, particularly between Pandas and the other two options here. So Pandas, you can see, takes a very long time to run. It's shown in second. Koalas is somewhere in the middle, but closer to the PySpark option, and PySpark is the quickest. I would put an asterisk on this based on my experience. Koalas does not work well with very wide data sets. So if you're doing something like NLP or something where you have many dummy coded variables, and those features are, they're much more of them. When you get those wide data sets, it can't handle it. So I recommend using the PySpark option, if at all possible, when you have really wide data sets, or you're going to see either a slowdown or your cluster will crash completely. So that is my one tidbit of advice. So instead of using slides, I'm just going to go through, and I made a lot of markdown text, and I'm going to go through that instead of slides, so we don't have to go back and forth constantly. So the main thing that you have to do before using Koalas is A, import the Koalas package. B, you have to change your Spark data frame into a Koalas data frame. Then you can use Pandas in just the same way as normal. And then if you want to turn it back into a Spark data frame, you'll have to do that. So quickly, the Koalas, you read it in. This is actually specific to Databricks. I don't know if this is available on any other platform. I've never tried it elsewhere, but it is something made by Databricks. You import the Koalas package here. And then the next thing that you'll do is actually take our existing Spark data frame and do 2 Koalas. That transfers it to a Koalas data frame. And then you can use the Pandas just as normal. The reason I'm using this, there's a couple reasons you would want to use Koalas. A, if you don't know PySpark yet, or you're struggling with it and you want to take existing Pandas code and parallelize it, or say you have existing Pandas code that hasn't been translated into Spark yet. That would also be a really useful use of Koalas. But the reason that I'm using it here is in Spark, the way that you change something from a long to a wide data set is very complex and convoluted. It takes like 5 or 6 lines of code. It's hard to understand, and it just, I don't like using it. Whereas in Pandas, it's extremely simple. It's like a one-off, really easy to do function. So in this case, I'm taking my Koalas data frame, running the simple pivot table that you've probably seen in Python before, taking my indexes and changing it so that each column for it has a year, so you can see that down here. If we scroll up, we can see that each row has a skill group penetration percent, but it has a different value for every year. So if you haven't heard of that, we call that a long data set. And we want to have each individual year be its own column, because the other data sets we're working with has a different column for each individual year, and that's the basic format that it uses. So we have to have everything in the same format, or we won't ever be able to merge it together. So now, after running this, we have the display skill penetration wide. Our result now has a different column for every individual year for the skill penetration, which tells us a little bit about the skill or the capacity that already is available in these different industries. So when we actually look at talent migration, we can identify which individual skill groups are in high demand, have a lot of capacity already, or and look at the ones where there isn't a lot of talent that exists in these different industries, and maybe countries that have more of, say, the tech skills. If a tech skill group is in higher demand, maybe they have less talent migration coming to them from other countries, or more. We'll have to look at that. So that is available here. However, you never really want to have a different column that has that's only an integer. So this is something we want to change. So looking at this, the next thing I'm going to do is show you how to rename columns. You can see the basic syntax in here. So I want to rename multiple columns in my PySpark data frame. So we're going to use with column renamed. And with that, all you have to do inside it is put the old variable name in a double or single quotes, a comma, and then the new variable name. The way that it's a bit different than Pandas is you actually have to string everything together. So if you want to rename multiple columns, you're going to have to write this out more than once. So you can see that down here with column renamed. I took the 2015 data and renamed that column, but I had to do it again for 2016, 2017, and 2018. Strung that together, and eventually with that skill penetration wide, you can see now that instead of one skill penetration a column, we have 4. So that's really useful. So we can actually take it and merge together with data sets like this that it's showing here. So this will be something that we'll eventually merge into. Are there any questions before I move on? All right. So the next thing that I wanted to do is see, in looking at those skill groups, I really wanted to see how balanced the data was. I wanted to see basically the number of rows that is in each skill group category, just so I would know throughout the analysis, and maybe I would want to make a column for each industry or focus on one industry over another. So in order to count the row, do a row count by group, we use the group by that we've already seen. And after that, it's simple. You do a dot count. And then if you want to actually show the result, you can either wrap that in display or do what I did here and add dot show to it. And we can see that the specialized industry skills are like more countries have those that the specialized industry skills recorded. So this is pointing to a potential problem with, like, some countries may have reported some industries and not others. So since we're not seeing balance here, later on in our data set, we're going to have to be really cognizant of missing data when we try to merge things together, because this is a possibility that just in general, one country may not record as many tech skills as another country. And we're going to see that that actually is an issue later on in this class. So the next thing that we want to do is actually take and drop some columns. So another one of our data sets we're working with is the migration from country to country. So you can see here that we have a base country. So basically where the talent is leaving from and going to. So the target country would be where the talent is eventually ending up. So migration from, in this case, this example, they're coming from United Arab Emirates, and they're going to the target country, Afghanistan. So we're looking at that movement between country to country. So it looks like these are positive for the first three. So there were more people moving from the United Arab Emirates to Afghanistan than were the other way around for 2015, 2016, and 2017. In 2018, you can see it switched and is actually, there's more people migrating from Afghanistan to the United Arab Emirates. So in general, the rest of our data has only one country name in the individual data sets. So there's no target country and base country. That presents a challenge because we want everything to be at the same level. So I'll tell you how to fix that in a second. But first, a best practice with working with big data is to get rid of any columns that you don't need. And to do that first before any data munging. We won't be doing any geospatial analysis in this class. So we don't really need the base latitude and longitude and the target latitude and longitude. So I'm going to get rid of those so it doesn't clog up our data. The best way to do that is to use the drop function, since we have a lot more columns than we're dropping. So we're keeping more than we're dropping. In that case, you'll want to use this particular function. We would have the base latitude, the base longitude, target latitude, and target longitude. For all of these Python users out there, the big difference between, in a lot of cases, between PySpark and Pandas is that usually in Pandas, this would sit within, these variables would sit within a list like this. That is not how PySpark works. So in general, you'll see that they're usually, each column is just listed in quotes, offset by commas, and that's pretty much it. So if we run that, now we see that our latitude and longitude columns that we told it to drop are now gone in our data set when we list those columns here. To just show the other side of the spectrum, I took the time, and you wouldn't want to do this in real life, but I took our migration country and I selected everything but the latitude and the longitude. This code here is identical. It does the same exact thing as the drop does up here. But I wanted to show you how to select and do it the other way, because you'll need that, and just show that there's two ways to do this. This one requires more typing and is more complex, so you probably wouldn't want to do that. But the actual syntax looks identical. So instead of drop, we put select here, and we have columns offset by commas here. And when we list those, we can now see that just these two data frames look identical, even though we use two different functions. Question, usually in pandas, when we drop some columns, we set the axis. So in this case, you don't need to do that. So in general, it's going to assume that this is a columns here. If you were going to get rid of rows, you would actually use a different function that I'm going to show down at the bottom. So the ones that I'm going to show you, we would actually be only those columns. One thing that you need to know about Spark that is very different from Python from like an under the hood perspective. And this might explain why you don't use the axis in PySpark. So in Pandas, I'm sure you already know, in Python, everything is indexed. The rows are indexed. So each row is assigned a number from 0 to however many rows there are. PySpark does not have that. There are no row indexes in PySpark. So you can't refer with like numbers to any of the rows. Also, every time you run something, unless you explicitly tell it to sort by a certain column, the rows are going to be in a different order every time. So that's something to keep in mind. You can't like take the top value without actually taking and ordering your data frame, because every time that top value is going to be different. When there's some reason that you need an index, that's another reason that I didn't mention to use Koalas here. So if you need to take advantage of those row indexes, Koalas does have those row indexes. So keep that in mind. The reason that they do it that way is for a speed perspective. So the only reason you would be using PySpark is to actually speed up the calculation. So keeping track of all the rows actually really burdens the computing power, and it takes a lot of computing power. So they removed it from the data frames that they have. So that's a big difference that you need to be cognizant of as you run.
Kelsey,
Mm-hmm.
sometimes I got a data frame that I get the last result and apply to the current registry to make to do an analysis how the current registry comports with the last registry.
Sorry, can you elaborate a little bit more on what you mean?
We have a data set with numbers from yesterday and numbers from today. And I get the numbers from yesterday and put in a new column in the current registry from today.
You mean last class? I don't know what you mean by yesterday.
Last.
Yeah, so the code is different this time around. Is that what you're asking about?
Yeah.
Yeah. So every time we have a session for the class, there's going to be a new code added in. So if you go into session 2, you're going to see the session 2 code. There were some errors in session 1 and I added to it. So it's going to look different. So you would want to pick up that new notebook. Does that answer your question?
No.
Okay.
Because you said that there's no order in Spark. So in Pandas, I set a data frame with the row index and get the row 1 gets the value from the second row and put in a new column in the row 1 and renaming that second row as last registry. Do you know what I mean?
Yeah, I think so. So that's what I'm saying. There are no row indexes in PySpark. That doesn't exist. There is no row index. So that's not something you can do in PySpark at all.
Okay.
So in order to do that, you have to change it to a Koalas data frame, which is what I showed up here. There is no row index. So if you need to keep the same order of rows, you'll have to do an order by, which I showed at the top of this code. Otherwise, it's just not something it can do for speed reasons.
Okay. Thank you.
Does that answer your question?
Yes.
Okay, great. All right, so here we go. You will notice, though, that there are column indexes. So that's something that you can utilize if you need to. But changing to that Koalas data frame is the only way that you can utilize a row index. Now, so real quickly, we've already gone over how to do this. So, but this is something I need downstream. So I want to, because this data set does not have the only one country. Every country is listed multiple times in the base country. We won't be able to merge this in with our country data sets that have a country for every row. It will end up making duplicates as we go through it and use it in practice. So we need to do something and rearrange this in order to get it in the same format as the other data frames we will be using. In order to do that, we're going to do exactly what we did above, and we're going to take that actual net per 10K 2015 to 2018. We're going to do that and create an average overall value for each individual country. So that's going to take all of these the different target countries and find an average for all the United Arab Emirates from all of the different countries and make an average of the individual numbers at the end here. So we would run this and we would get a data frame that looks like this. So now each base country has its own column, and there is an average for the migration from overall for each individual country. So we can see here that in general, people are migrating from Luxembourg to other countries because we're seeing a positive number here. And then you can think of it as an average of these target countries. So here I'm just quickly, before I do anything with a different data set, it's good to visualize it so I know what's in there. So that's all I'm doing here. Now the next thing I want to do is show you how to use joins in Spark. So these comments here are all this is. I listed all the data frames I'm using. And then down here, I listed all of the columns so that I would be able to easily pick out the common columns between all the different data frames here. So this is just me giving myself some useful information for the joins below. So we want one row per country, and that's the end goal here. So I'm going to, in this case, take some of the industry data sets and actually merge them together. So I'm going to try to join migration industry and industry growth. So if we look at industry growth, it has a row for each country, and it has a row for each industry within that country. And then if we look at migration industry, it has also the country information and an industry name. So these are already in the same format as one another. So they're a good one to start off with to join them and see what happens. So in general, the easiest way to join in Spark is shown as follows. If you wouldn't specify the first data frame and the second data frame and say that they're equal, you would run into the problem where it would actually create duplicate columns if you don't specify for each data frame. So all the different types of joins start with, I would call it your driver data frame, followed by .join. And then the data frame that we're looping in and trying to join with industry growth will be the second one listed here. Order does matter in cases of some joins. Order does matter. In this case, it matters less because we're doing an outer join. So before we get to the difference between outer, inner, all of that and how you specify it, for each individual column that you want to merge on, make sure you take first the data frame that you're talking about. You can have that country code here and tell it what it is equal to in the second data frame. So in migration industry, this is equal to the country code as well. And then you will use, and I think this is called an ampersand, but like for the and, this is how you do it. And you make sure and you go down and you list each one of these columns in each data frame and say to merge on all of these actual columns. And then finally, after that, this all needs to go, each one has to go in its own parentheses. And then you add a how, and then what type of join you want to do. I have a link here that you can go to get more information about PySpark joins. I can show that here. So in general, the default for PySpark is an inner join. An inner join takes, and I'm not going to go over this in much detail, this hopefully you've either used SQL or Python and you know what this is. But an inner join is going to take only the matches between the two data frames. An outer join is going to keep everything, matches, non-matches from both data frames. One thing to keep in mind is it's going to take the column names from your driver data frame and not the industry data frame if the column names are different. So that gives us and keeps everything. So a left join is actually taking and keeping these number of rows constant in our driver data frame, looping in another data frame, and if something is in this data frame and not in this data frame, it's going to be dropped from our data set to keep the rows constant from here. However, if there is a row in this data frame that's not in this data frame, it will show up as missing in this case. You would always want to keep an eye on your row counts when you do these. When I first started coding, this was the biggest mistake I made along the way. Is that if I had duplicates in my data frame, the row count would increase when I was trying to do a left join. Right join is the exact opposite of what I just said. So it keeps the number of rows constant in your second data frame that you list, and it matches values with the first data frame. So this is going to be the exact opposite. So if you have something in here that is not located in this data frame, it's going to take and have missing values, whereas they'll be dropped from the other data frame. All right, and I'm not going to go over the cross and anti-join. I'm just going to go over this. They're sometimes useful, so it's good to look up if you're interested. But you can actually see down here, an inner join is is the default. So we're going to have that inner join here. And you can see that a full outer join, we can specify any of these. So the only thing that changes for the code is actually that by value. So the last value that's written in quotes. That's the only thing you have to change when you go through. And in general, the results of this are going to look the same as like the SQL versions of this code. So if I run this, the next thing I want to do, because there was like a red flag at the top for me, is to see if how these merged, how much missing data is in this data frame. That's why I went with an outer join, so I could easily check this. So first, I'm going to take the rows in our existing data frame and just see how many each of them had. So industry growth had a little over 7,000 rows. Migration industry, by contrast, had 5,282. So that's my first red flag there. So there's clearly going to be missing data in one of, and that is in this data frame, but not in this one. So to learn more about that, my usual strategy is to actually, so first look at how many rows are resulting data frame. You can see here, this is after the join. You can see that the number has gone up. So what that tells me is there's not only column rows that are in this data set, but not in this data set. There are rows that are in this data set that are also not in this data set. So our rows have increased a lot, which means that there's a lot of missing data going on. So that's a red flag, and we're going to have to deal with it in some way. So down here, I'm showing two concepts. First, there are two ways to filter, and we talked about that. I would talk about this earlier in the class. So one way is to do it more like the SQL way, where you have a where, and inside you have a condition on whether to keep a row or not. In this case, I chose a column that was located in one data frame and not in the other. So industry growth, our larger data frame, had the growth rate in 2018. So I want to check how many null values are in this new column that was in our merged data frame, and count the number of null values. I'm seeing that there's 2,449 missing in that growth rate 2018, telling me that there are 2,000 rows, over 2,000 rows that are in this data set, but not in this data set. I did the exact same thing with the industry, migration industry. So this column is only in the migration industry data frame. So I'm going to do that where, and then have my condition here. This is an example where you can index with columns, just not rows. And then I'm subsetting to only those null values, so the is null. And then I'm doing a row count here as well. So now we're seeing even more missing, which is what we would expect, that are in this data frame, or in this data frame, but not in this data frame. So basically, as is, this data set is pretty much useless when we put them together. So we have to think of a creative way around this. And this is, I'll go over some of this. I don't know if I'll get through all of it. So we have missing data. We need to figure out how to fix it. So my hypothesis is that the different industries, some of them, the industry names are in there, and some of them are not. So my strategy would be to actually aggregate those up. So find different ISIC section names or industry types that we want to focus on, where we have a hypothesis that it may correlate with migration, telemigration overall. So one of the theories that I have is that there might be more migration to certain countries if they have a higher tech migration number. Because in a lot of cases, we're seeing that people come to the United States who have highly technical backgrounds. Maybe that's true outside of the United States as well. And we could see people moving from countries to more industrialized countries to have that tech talent. So that's what I'm actually going to explore here. So the first thing that I did was I wanted to see what the ISAC section names, which are basically the buckets that different industries are inside. So the bigger buckets. So we can see here that we have health and human services, education, so on and so forth. I wanted to identify which ISAC section name had the technical talent in it. It turned out to, and I checked a couple, I believe, but information and communication is where the tech sits. So I went in, and this is showing the other way to filter your data frames with the filter function. So in this case, I took migration industry and the ISAC section name, and I wanted to subset it to just those that hold the tech talent, which is information and communication. The goal being to show the industries that are located within this group. So you can see here there are two buckets. So communication, so a lot of news and film categories in here, and also some technical ones as well. So we would consider wireless and computer networking to be technical industries. And you can see that there are some here. So what I want to do is actually take that and create a flag for all the different rows in our original data set that say when it's a tech industry and when it's not a tech industry, so that we can look at the talent migration for those tech industry companies, or those tech industry, the tech industry migration. So one of the best ways to do this, because there are quite a few tech industries that are showing up. So if we did and took the approach where we actually listed out, similar to this, where we actually listed out each individual column, we want to do something a little more efficient here. So if you're basically filtering on many values, so instead of doing column 1 equals this value, or column 1 equals this value, and column 2, so on and so forth, we would end up doing that, I don't know how many are here, but like 10 times. We don't want to do all that typing, and it's harder to read. So the way to get around that is actually to take that migration industry. This is very important. So anytime that you create a new column, you're going to use with column to actually create a new column if it has values that are based on other values in your data frame. I give the general syntax for this up here. So you have our data frame, we have with column, we have the new column name, whatever you desire it to be, will be the first argument. And then after that, it will, in this case, we're doing something that's a condition. So when one column value is this value, then it has a value if true. So you list the condition and the value if true, and then you'll add otherwise. So if it's not in this condition, we give it the value to assign if it's false. So our example is here. So our with column, we're going to call this tech industry because it's a flag and whether a industry is tech related or not. Now we're going to use when. You're going to notice that in certain circumstances, you're going to have to use the call function to actually specify that a value is a column instead of doing the DataFrame dot industry name. For some functions, this is required. For some functions, it just isn't. So always, the best way to figure this out is honestly to go into the documentation and see which one they use, because it doesn't seem to follow any rhyme or reason that I've ever noticed. So we're making condition. When industry name is in the tech industries that are listed up here in this list, it returns technology industry. Otherwise, when it's not in this list, it writes not a technology industry. That creates that new column for us. And real quickly, and code on the fly a little bit here, migration industry, we're going to use the select function here and take just that tech industry value. And now we're going to actually, I think display might be our best option here, and display the result. So now we can see here with that this actually did work. I don't see any missing data. So our first row is not a technology industry. The second is technology industries, so on and so forth. And we can even just print that entire data frame so we can actually do some spot checking as well. So here, this first defense and space is not a technology industry. It was marked correctly. These next three are clearly technology industries, and they're being marked as technology industries, which is, it looks correct. So going through, you could do some spot checking. It looks and appears that it did it correctly. So my whole idea with this is to group larger industry groups together and find a sum over all those different groups of the migration in those groups. So in this case, we are actually aggregating all of the migration numbers and summing them together to comprise just the tech industry values. So that is, in order to do that, we're using aggregate, and instead of average, this time we're using sum. It's going to sum those net per 10,000 Ks, and it's going to give them the names that I listed here with that alias function. I'm going to take that and string along. I want to actually just subset the data to only those technology industries. And then I'm going to actually drop the tech industry column. So I'm going to show this one by one here. So first we'll run this, and we can actually do a show here. Whoops. So you can see here, before I commented these out for now, we have a tech industry, we have our different sums, and we have both tech industries and non-tech industries listed in our data frame. I want to subset to just those technology industries. So in order to do that, I do a filter to filter for just those that are specified here as technology industry. And then I can actually drop this to get rid of this tech industry altogether, because they'll all have the same values. So the end goal would be to find and actually merge this into the different data sets, so we can see if there is a correlation or association between whether there's high tech migration and whether it is related to migration as a whole across in all those industries. So that's all the content I have for today. I'll stop for questions in just a second. But in case you want extra practice, I put a couple exercises down here. Using the grouped aggregations and asking you to use the select and drop functionality. And I also gave a challenge question. So this has many steps in it. and it's going to be difficult or more difficult, but it's going to look like a real life scenario. So if you want to do these, they're not required, but if you'd like to do them, they're here. I can go over the results in the next class of these, particularly this challenge question. Now, just to open it up to questions, are there any questions before we log off?
Just one general question I had on the outer join.
Absolutely.
Like in my background is in SQL, and if I have two tables, A and B, and I'm joining on a key or two between A and B, and I do a left outer join, so I want everything in A, whether or not they match in B. Typically in SQL, I would only get more records than the A table has if there's duplicates of A in the B table. And I'd be getting some degree of Cartesian. Is that not what's happening here?
Yes, it's actually exactly what's happening here. We didn't use the left join above, but that's if there are duplicates, that's you'll see that row count increase if you're doing a left join, and it can be called left outer or left in this. I think they're equivalent, but yes, that number will rise. And that's something that I messed up in the beginning of my career a lot and got me in trouble. So it's something I keep my eye on with these row counts. I think so here, both I looked at how they changed. It's a little bit different because I'm using an outer join here. So, but if I change this to left, theoretically, let's just do it, see what happens. So there are no duplicates in my data set. So the driver data set, the rows are the same in the final migration growth. And so you're seeing that, and then you would see nulls for every non-match here. So just like you just said, that's what's going on here. If I had a duplicate row, it would be a one row larger.
Okay. All right, thank you.
No problem. Are there any other questions? So one question I had for you guys. So I've noticed that the attendance in the morning session tends to be a little bit lower than the evening session. Maybe you could take, before you get off, the time to put in the chat whether if I, like, say, canceled the morning session, if you could actually would be able to come to the evening session instead. That would be helpful, because if I'm having low attendance in the morning, it's harder to take time in the morning away from my job. So, yep, I would like some guidance on that, if it would be helpful, if people could still attend if it was the evening. And feel free to, in the next 2 minutes, ask any other questions you have. All right. Okay, so that's good. And right now the evening sessions are available too. So both of them are available, but I'd like to do it once if I can. Okay. Yep. All right. So from that note, I do think that I am going to cancel the morning sessions and just keep the evening sessions. So all of this will then happen in the future in the evening. So just so everybody in here knows that, I'll be canceling it, but you're welcome to come to the evening session only. That'll be the only option. Thank you. Have a good day.